Okay, here we are with our examples. We're going to start with the nitrate ion. If you watched the last video, then you know we've already counted up the number of electrons. I have those numbers written up here. So let's start with nitrate, 24 electrons. What goes in the middle? Well, we're going to put nitrogen in the middle. That makes sense here. Nitrogen in the middle here, all right? Then we're going to make our single bonds to all our oxygens here. It means we have 18 more electrons to go, all right? We've used 2 in each single bond. So let's fulfill the octet rule for all the oxygens. Here we go. Excellent. Okay. There, I've used up all my electrons. But if you look at it, you notice there's a little problem with nitrogen here. It's not fulfilling the octet rule. I'm going to pick one of these oxygens to make a double bond with. And I'm going to select this one on top. Left, right, top, doesn't really matter. But I'm going to select the one on top. So you can see the octet rules are filled for nitrogen as well as all the oxygens. But let's now talk about formal charge. All right? If we look at this, all of our formal charges for these 4 atoms need to add up to -1. So let's look at this oxygen on the left. Oxygen has 6 valence electrons, but how many does it appear to be bringing in this case? Well, we have 1, 2, 3, 4, 5, 6, plus the 1 it brings to the single bond, so it appears to have 7. Supposed to have 6 electrons, actually has 7, charge of -1. And if you'll notice the oxygen on the right, same deal. It's got 6 electrons in lone pairs plus the electron in the single bond. That has a formal charge of -1 as well. This oxygen on the top, it's all good. It's got 4 electrons in the lone pairs and 2 electrons in the double bond. Therefore, it's got 6 electrons, appears to have 6, everything's great. But if you'll notice, -1 and -1 do not equal -1. We need a positive in there somewhere. So nitrogen. Nitrogen is supposed to have 5 valence electrons, but in this case, it brings 1 to the single bond, 1 to this single bond, and 2 to the double bond. That gives us a grand total of 4. It's supposed to have 5, but it only appears to have 4. It's like it's lost an electron. So we get a formal charge of +1 on the nitrogen. And if we add all those up, that equals -1. Now on to resonance. This is a nice complement to what we're doing with formal charge. This double bond doesn't necessarily have to go to this oxygen. It could go to the one on the side. And so I'm going to use arrows to indicate electron pairs moving around. And so let's say this electron pair here moves into this area to make a double bond. Well, that would give nitrogen more than 8 electrons, and we can't have that. So this double bond kicks out. That lone pair kicks out to the oxygen, and we're left with this. And if we go through formal charge again, you can see that the nitrogen in the middle looks exactly the same. That's going to have a plus charge. All right? Now the top and the right-hand side oxygen are going to have our negative formal charges. And when we talk about resonance structures, we have to go through all of them. So in this case, there's one more that we can draw. We can get that double bond going to the right-hand side oxygen, and after I get all these electrons drawn in, okay, now we can write our formal charge. We get a -1, -1, +1. So nitrate, the nitrate ion, NO3-1, would have 3 resonance structures. I'm now going to do SO4-2. All right, SO4-2 is going to be a little bit longer. All right, so we have 32 electrons. Sulfur goes in the middle. We have our drawing here. Okay, so we've used up 8 electrons. We now have 24 more electrons to work with. And as we start fulfilling the octet rule, there we go. We've used up all 24, everything's done, great. All right, but now we're gonna go through and we're gonna get the formal charge for all of these. Hopefully you saw a pattern with oxygen back here. When oxygen forms that one single bond, it's going to have a formal charge of -1. Oxygen is supposed to have 6 valence electrons, 1, 2, 3, 4, 5, 6, plus the one it puts in the single bond that gives us 7. So we're going to have a -1 formal charge here, 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 and here. But with a -2 charge on the sulfate ion, we need a +2 in here somewhere. Sulfur is supposed to have 6 valence electrons, but here it's putting 1 into each of these single bonds. That only gives us 4. So it's supposed to have 6. It appears to have 4, so it's like it's lost 2. This gives us a +2 formal charge, and we add it up, we get -2. But there's a little bonus, yay, for sulfate, all right? What has been found, and the way that we draw things, is we want formal charges to be minimized. We want as few of them as possible, and we want their charges to be as small as possible. So in this case, because sulfur is in the 3rd period, it can have an expanded octet. So we can switch this up a little bit. If I take this lone pair right here, move it out, now the formal charge on this oxygen is 0, and the formal charge on sulfur is +1. If I then take this lone pair and form a double bond, the formal charge of oxygen is 0, and the formal charge of sulfur is 0. This is the accepted drawing for the sulfate ion. What we had on there before with a +2, -1, -1, that is an acceptable version, but this is the accepted version. Little vocabulary thing there. Anyways, now we can draw several resonance structures. I'm not going to draw them all. I'll draw 2 more, all right? And you can see that we can flip around these double bonds. And so what we can actually have here is something that looks like this. Or we could have the double bonds going up and going down. There are several resonance structures for the sulfate ion. Make sure I get my formal charges in here. -1, -1. All right. I won't draw them all up, but you can see that sulfate is a very stabilized ion. That's why it's so common. It's very hard to break it apart because that resonance binds the oxygen and sulfur so tightly together that we can't ever really tear them apart. The other examples I'm going to do in the next video. All right. So if you want more examples, feel free to watch the next.